How do senior D, JK, and T flip-flops work in digital electronics? Imagine flipping a switch that remembers whether it was on or off even after you turn it off. That's what flip-flops do in digital circuits. They store bits of data. They are the basic building blocks for memory, counters, and registers in electronics. Today, we're going to explore how four common types of flip-flops work. Senior, D, JK, and T each has its own way of controlling and changing data based on inputs and clock signals. Let's start with the senior flip-flop. It has two inputs called set and reset. When the set input is high and reset is low, the flip-flop sets its output to 1. When reset is high and set is low, the output resets to 0. If both inputs are low, the flip-flop keeps its previous state. But if both set and reset are high at the same time, it creates a problem called an undefined state. These flip-flops change their output only on the edge of a clock pulse, making them useful for controlling specific bits in a circuit. Next is the D flip-flop. It has just one input called data and a clock signal. When the clock signal triggers, the output takes the value of the data input. So if data is 1 at the right moment, the flip-flop stores a 1. If data is 0, it stores a 0. This makes the D flip-flop perfect for storing data bits in registers. It also avoids the undefined state problem of the senior flip-flop because it only has one data input controlling its state. The JK flip-flop is a smarter version of the senior flip-flop. It has two inputs, J and K, which act like set and reset but with a twist. When both J and K are high at the clock edge, the flip-flop toggles its output, meaning it switches from 0 to 1 or from 1 to 0. If J is high and K is low, it sets the output to 1. If J is low and K is high, it resets the output to 0. When both are low, the flip-flop keeps its current state. This toggle feature makes JK flip-flops very flexible and popular in counters and control circuits. Finally, the T flip-flop is a simplified version of the JK flip-flop. It has just one input called T. When T is high at the clock edge, the flip-flop toggles its output. When T is low, it stays the same. This makes the T flip-flop ideal for counting and dividing frequency because it switches states with every clock pulse when T is high. It's a simple way to create toggling actions in digital systems. All these flip-flops work in sync with clock signals, making them essential for sequential logic. They help store, control, and toggle data bits in digital electronics. Whether you need to remember a bit, count pulses, or switch states, these flip-flops are the core components that make it happen.